Far away, in the depths of the universe, there are cosmic monsters so powerful that not even light can escape. These are black holes, mysterious objects born from the death of giant stars. But what are they really? How do they form? And what secrets lie hidden within their dark interior? Today, I'm going to show you just how shocking a black hole can be and why nothing can escape from one. First, let me tell you about their origins. To understand black holes, we must first look at stars. These stars live for millions or even billions of years, burning their nuclear fuel and generating energy that maintains their brightness and shape. However, not all stars have the same fate. When an extremely massive star exhausts its fuel, it can no longer sustain itself against its own gravity. The core collapses violently and the star explodes in a supernova, releasing enormous amounts of energy into space. What remains after this explosion is an incredibly dense and compact object, with gravity so intense that nothing, not even light, can escape. Not all stars can end up as black holes. Only those with a mass much greater than that of the Sun, at least 20 or 30 times greater, will have enough gravity to collapse in on themselves after exhausting their fuel. Smaller stars end their lives as white dwarfs or neutron stars because their gravity is not strong enough to create a black hole. The mass of the star is the key. The more massive it is, the stronger its internal gravity and the more violently it will collapse at the end of its life. This collapse concentrates all matter into a tiny point, forming the singularity of a black hole. Thus, only the most gigantic and powerful stars in the universe can generate these extreme objects that defy our understanding of physics. Although black holes are one of the most fascinating objects in the universe today, their existence remained a theory for decades. It all began with Albert Einstein and his theory of general relativity, published in 1915, which described how gravity can bend space and time. From their equations, some scientists realized that there could be bodies with such intense gravity that not even light could escape from them. For many years, this seemed like an impossible theoretical idea to test. They couldn't be seen directly, and the word black hole didn't even exist yet. It wasn't until the 1960s that astronomers began to find indirect signs of these cosmic monsters, stars moving in strange ways or emitting very powerful X-rays in certain regions of space, indications that something invisible and extremely massive was there. The name black hole was popularized by John Archibald Wheeler in 1967, and since then, scientists have focused on searching for real evidence. For decades, telescopes and observatories analyzed the behavior of stars and gas in nearby galaxies, building evidence that these objects were not only possible but actually. The big milestone came in 2019, when the Event Horizon Telescope project captured the first direct image of a black hole's event horizon in the galaxy M87. For the first time, humanity was able to see the shadow of one of these giants, confirming what Einstein and scientists in the 1960s had predicted: black holes are real, and their power exceeds anything we can imagine. Not all black holes are the same. Scientists classify them into several types, depending on their origin and size. The most common are stellar black holes, which are born when a very massive star dies in a supernova. Their mass can vary from a few times that of the Sun to dozens of times greater. They are the most common and lurk throughout the universe, slowly devouring matter from nearby stars. Then, there are supermassive black holes, the true cosmic giants. These can have millions or even billions of solar masses. They are found at the centers of almost all known galaxies, including our own, the Milky Way, where Sagittarius A resides. The most mysterious thing is that scientists still don't know exactly how they form. One theory says they grew slowly by absorbing gas, stars, and other smaller black holes. Another suggests they were born already enormous, shortly after the Big Bang. Although black holes appear simple from the outside, their structure is much more complex than what might imagine. At the center lies the singularity, a point of infinite density where gravity is so intense that normal laws of physics cease to apply. All matter that falls into a black hole ends up here, compressed into an infinitesimal space. Surrounding the singularity is the event horizon, the invisible boundary that marks the point of no return. Once something crosses this boundary, it can escape, not even light. That's why black holes are completely dark. Many black holes have an accretion disk, a kind of ring of gas and dust that spins at incredible speeds before being devoured. This disk can emit enormous amount of radiation, especially X-rays, which is one of the ways astronomers detect black holes. Some black holes also generate relativistic jets, streams of particles that are ejected at nearly the speed of light from the black hole's poles. Although nothing can escape the event horizon, these particles are still ejected into space, and their energy can affect the formation of stars and entire galaxies. Now, what would happen if you fell into a black hole? If you were to approach a black hole, the first thing you would notice would be its extreme gravity. This intense force would begin to stretch your body toward the black hole and compress it. Literally, a phenomenon known as spaghettification would literally turn you into a thread of matter as you fell. Time would also behave strangely. To you, everything would seem normal, but a distant observer would see you moving increasingly slower, almost stopping at the event horizon. This effect is called time dilation and is one of the most surprising predictions of Einstein's theory of relativity. As you cross the event horizon, the point of no return, nothing could escape, neither light nor the information you carry. The universe behind you will warp, with stars and galaxies bent by gravity, creating a visual spectacle that defies all human logic. As you continue falling toward the singularity, gravity becomes infinite, and the laws of physics we know no longer apply. Space and time combine in ways our minds can barely imagine, leaving the interior of a black hole as one of the most extreme mysteries of the universe. This whole topic of black holes is really very interesting. If you have any interesting facts about black holes, share them in the comments. I hope you liked the video. By the way, this is my first video and I hope it wasn't too bad. I also want to emphasize that I'm trying to learn English, so forgive me if I mispronounce a word.